Good morning, friends. I suppose I'm audible.
Good morning, sir.
Yes, sir. Yes,
Good
sir.
morning. Good morning. So, my friends and colleagues, and all the participants who have joined this VC, today I would like to share the available technologies that are available to control or to address the quality. Further, let me tell you that our chairman, sir, has taken a special initiative for adoption of the technologies. Like he has taken a lot of improvement in our operation part. Our IT division has done a lot of work in the operational segment where NHAI apps have been developed. Similarly, during the construction, we have to adopt or we have to take the available advantage. We have to take the advantage of available technologies like automated machine guidance control system. So today we will discuss this automated machine guidance control system. What are the things? Let me share my presentation here. So, as our chairman sir has directed, and we are adopting these technologies, we are trying to do some work with this technology. Accordingly, our member sir, Anil Chaudhary sir, has guided us to process the complete system of its implementation. Before that, let me inform you that this technology is being implemented in NHAI at one of its project at Lucknow, Kanpur section by our project director Saurabh Chaurasia. He is doing a dedicated work in this field, and even he has created a audio clippings for all of us. So I'll share that audio clippings also with you all. And before that, well, let me tell you that this technology was first started by our ex-member R.K. Pandey sir and his team. When Giri Saab, Naveen sir, they have taken this, they got the cognition of this technology, and then they included one of the project in this Lucknow Kanpur. And accordingly, that work has been started by this PNC, and PNC has consulted the Trimble to help us for implementing this technology. So let me tell you, this automated machine guidance control technology is basically a combination of geospatial data, instrumentation, and artificial intelligence. So we usually know that we have two phases, construction and operation. Now, in construction, we are struggling with quality and of course certainty also. So with this technology, we have tried to address the compaction part, which is generally having the layers and certain SOPs has to be followed. Also, the drainage is also one of the factor for the quality. So this will be taken later on. But today we will address the compaction part. Of course, the certainty is also one of the thing, and this certainty is being addressed by what Chairman sir has motivated us for through digital twin. In digital twin, we will create a model of our project. The whole thing, what the whole provisions, the whole components, what we have envisaged in schedule B and C, that will be converted into a model, and that model will be a digital twin. And during the construction, the information will come from the site, like this technology, this automated machine guidance control system. From this, information will come, and gradually the project will virtually grow up in our model also. So this will be done through the digital modeling. That will also be discussed later on. And let us see today the compaction part. In operation, we have already done some work with the NSV and drone analytics, NH1, Tatpar app. This is also one of the things that we have already taken up through our IT division. And the traffic safety, ATMS and incident management, all these things have been taken up by IHMCL. So now let me concentrate on this automated machine guidance and control technology. As I already told you, this is being implemented in Lucknow Kanpur package. In this, as you are seeing that the design part, the what we are getting this design data, the design part, the longitudinal section, the cross sections, all those cross sections from open civil and this Bentley software or Autodesk software, that design is converted into 3D model. That 3D model is being conveyed to the machines at site, like our grader, our compactor, our paver, even the earthwork also. And all these things are being controlled by the surveyor. So now this surveyor part will be shifted to uh, shifted with the technology of this GPS. So before that, let me tell you, today the contents are the governing IRC guidelines and the MORTH specifications, then the general process, then the basic principle of this technology. Then we will discuss available system to adopt the 3D automated machine guidance. Then what expected output I like to demonstrate that. Then its financial implication and implementation procedure, what we have adopted to implement in all our projects. In the present scenario, after observing the success on our package, we have introduced to DPR cell a text in the schedule D that I'll discuss with you in the last part of this presentation. So first of all, the IRC specifications where the compaction has been mentioned and compaction equipment have been mentioned. It is mentioned at para 4.3.3 of IRC SP 97 2013 that the intelligent compaction system has to be adopted. So this is one of the things that we have to address through this technology, and we are trying to adopt this. Further, there is also one of the things that we have to lay the embankment in the layers of not more than 250 mm. This is also one of the factors that we generally faces a lot of challenges. So this can also be addressed कि every layer should be done in the layer of 250 mm of thickness. See, this earthwork part generally is being done by the subcontractors and the petty contractors. So in that case, the quality has to be ensured. And that quality, even the main contractor sometimes is not able to address that. So let us proceed with the technology so that it automatically comes in the process. So that is what we have tried to adopt from this. So this laying the embankment or layers in, or subgrade in 250 mm of thickness or 200 mm, this can be achieved from this technology. Also, one of the things is this key, the level of the surfaces, our WMM surface or earthwork surface or subgrade surface, has to be remain in the tolerance limit of the subgrade. Tolerance limit is somewhere around plus minus 20 mm, and in case of subbase it is plus minus 10 mm. So these surface layers or the surface level has to be maintained in tolerances limit. So because where it helps us, because whenever some sag is there and the water may get accumulated in that sag portion, that will gradually uh, our pavement get deteriorated because of that. So we will try to keep the surface levels in tolerance limit through this technology. Further, in IC 97 itself, there is also mentioning about the laying temperature and the rolling temperature. So this can also be addressed when our paver is there. The sensors will be there and we can map the laying and rolling temperature. And now the compaction part. This is the main thing that is mentioned in para 4.3.2 of relative. Under relative compaction, let me read this particular text, what we are going to do with the help of this text. The compaction analyzer register all the CMV. CMV means compactor meter value. Here's this compactor meter value data and allows the operator to see the compaction result on the computer screen. This is what we have done in this technology. A computer screen has been provided in our grader, in our compactor. All this can be seen in a video. I'll show you. On the basis of the experience or on the existing calibration, the CMV limiting value can be used for each separate compaction job. Each layer means each layer or each particular segment. Now the compaction analyzer then indicates each area require the additional compaction. This can also be seen. I'll show you how this can be achieved. In some cases, compactor is accompanied with GPS. As I told you, this complete technology is related with geospatial data, instrumentation, and AI. So with this GPS, in which all the runs passes, passes, its position, utilization of the roller can be documented. So we have tried to document it in the form of color coding. The process followed in each of relative compaction of soil and bitumen are already mentioned in this paragraph. So this is what we are trying to do with the available technology in the system. Now, as you know, basically the highway deals with the compaction of layers. Generally, we have two type of materials, granular and bituminous, and our functions are layering with the provided thickness, then maintenance the moisture content. Today, we are discussing only the compaction part, because once we compact this, once we address the compaction, lot of hurdles will be removed. As you see, our Delhi-Mumbai expressway is attracting some of the criticism. But just because of this, just because we have missed some compaction quality, and our whole bituminous course is getting deteriorated at some of the places. But anyway, by adopting this technology, we can improve this. And for these functions, we are adopting this grader, soil compactor, paver. Then by doing this, all this thing, the controlling factors are what we need in the geospatial thing. It's positioning, horizontal coordinates X and Y, then compaction, then levels and degree. This can be achieved through the positioning can be achieved through GNS and DGPS, and compaction can be done by our vibratory based sensors and the rollers passes of the rollers. Again, levels can be achieved through auto level and this GPS. Temperature can be captured by the sensors and infrared. Now, this is our cross section, right? This is the Y. So X is longitudinal and this is Y coordinate. Z is vertical. So by controlling these three things in the geospatial, in the form of geospatial, we can improve our quality. And of course, there are certain things we are in the process of this adopting this technology. And I'll request whatever thoughts come in your mind, you please share with us, because we are expecting a lot of things from this technology, and from your data and from your feedback that can also be included in this. So here is the cross section, and these cross sections are being controlled with level and the positioning by sensors, software and DGPS for our embankment, subgrade, GSB, DBM, BC, these courses, right? Now, this is our bed. In this bed, this compactor or paver or grader is working. Now its vertical position, vertical will be controlled with this technology, where our compactor or where our grader or where our paver is moving, at what elevation it is moving. It is so precisely being captured. We are able to capture it to the tune of 20 mm, 15 mm, and with the use of this robotic total station, we can achieve it to the level of plus minus 5 to 6 mm. Further, its horizontal positioning can also be controlled. The equipment, the horizontal positioning of this equipment, and we can control the compaction part. Now, how this technology works? Basically, from the design, we already knows the XYZ coordinate of that intermediate level or intermediate layer or the finished road level. So we monitor the positioning of these equipments, our compactor, our grader, through this satellite data, geospatial data. So in this case, the 3D automated machine guidance control system links the design software with these construction equipments. Also, it integrates the computer within the construction equipment. What I have read in this intelligent compaction value, in that text, the computer in this construction equipment is linked with the GNSS to relay its positioning information, equipment's positioning information. It evaluates the machine's actual horizontal and vertical position relative to its location in a 3D generated model. What I have told you, in the starting, generally in this case, a 3D model is generated from our longitudinal and cross sections. That 3D model is being used and being compared with the positioning of this equipment. And accordingly, we get the results, we get the output, and based on that outputs, we can control our these four factors, that temperature, levels, compaction, and also the operator is capable to utilize this information from onboard computer to control the machine's equipment. The onboard computer is directly linked to the machine hydraulics. I'll show you. And that hydraulics are being controlled, that control the various operations. Now, this is the grader. This is the grader blade. On this grader blade, this portion, we are generally put this GNSS receivers. So these receivers guide the these blades through the hydraulics, and operator is able to guide these blades to achieve the level or in the layering operation. And this complete system is now free of all this uh, putting this stakes and strings. This complete this complete process of automated machine guidance automate the process of laying and compaction. You can see in the pictures कि generally we have to adopt this process of surveying, and the operator has to depend on the surveyors, and he generally gives the direction or directs कि, what level we have to achieve. So all this thing will be eliminated, and we can do the work even in day and night with the quality. And also the human safety hazards can also be eliminated with this technology. These are the things that we can fetch out from this technology. Now, let us discuss about the output of this grader. As you see, this green part and blue part in the end here. This is basically that portion where the roller or compactor or paver, or not paver, this grader used to raise by 250 mm and keep the layer in 250 mm thickness. And anything which is left or cannot be achieved, that is being recorded in the color coding form. So in this way, this technology can be used to get the data in the form of color coding for adopting the construction of embankment in the layers of 250 mm or 200 mm, that can automatically recorded in this system, and this data can easily be discussed with contractors. Even contractor itself will try to keep all the things within the tolerance limit, like laying of layers in the thickness of 250 mm. This challenge of laying the embankment in the layers can be achieved and can be bring to bring in the process through this technology. This is what we have understand from this, and we are sharing with you. Further, any enhancement in this can also be pointed out by you all so that we can proceed with that. Similarly, we can also get what FRL we have to achieve and what level we have achieved so far. This data can also be fetched out from this technology. Also, if we say about the stretch of 10 kilometers, so what level has been achieved, this is the OGL, and then what level has been achieved, what is the subgrade level, what is the CT GSB level, then what is the WMM level, and which are the stretches that has been achieved at what level. This can also be fetched out from this as an output from this complete system. Now, this is a compactor. In this compactor, we generally put this CM310 compactor meter in this roller. With the vibration of that, we can we can capture the compaction value, Here also the GNSS instruments is there to relay its position. Now in this process at present we have two things. We can proceed with our test bed in which we will do this sand replacement method for our FTD, where we have to achieve the 95% of lab density. In that case, we are generally doing this ki number of passes, we are deciding the number of passes to achieve this 95% of field density. And also at the same time, we can calibrate the field density of achieving the level of 95%, what CMV value is required for that. So that CMV value can be checked and can be feeded in this system to know the compaction of each part of our stretch, each part of our stretch. Now in this case, the number of passes. See, these are the number of passes where we have given a different colors. You can see where the number of passes have been achieved and where the number of passes has not been achieved, where the 2 number of passes has been done, where the 5 number of passes has been done. So with this data, you can see where the required compaction or required passes has been done in the stretch, and this data will help you to further deciding this we can proceed for the further layer or not. So this is the example of pass count, number of passes with the color display we can do, and also the notification in case of less compaction we can see. And here also the what I have explained you, we will calibrated the CMV value. So in this stretch, if you see the CMV value, we have decided somewhere around 20 to 12 for our compaction. So whatever stretches which are having the loose pockets of compaction, that can easily be seen here in this stretch with the blue part. So these are the loose pockets. Last Saturday, Secretary Sir was asking about what are the where we can do the test. So in this technology, from this technology, we can find the locations where the loose pockets are there, and we can do our testing in that location so that we can achieve the compaction in every part of our segment. चप्पे चप्पे पर हम इसको देख सकते हैं कि हमारा कॉम्पेक्शन वैल्यू क्या है. I have already informed you by reading that text ki how we are adopting that text in the form of working, in the form of output. So this is the compaction part. So we have covered the layering, we have covered the compaction, and now let us discuss with the paver. In this paver, the DGPS equipment is this, and it is connected with the screen. Here, one more thing is required is the robotic total station. This robotic total station brings the precision to the level of plus minus 5 to 6 mm. With the help of this, we can achieve this precision in the thickness. So, generally, we put this total station which guide this paving machine to lay the proper thickness of material, bituminous material or even WMM also. In WMM, we doesn't require this total station. We can do with the ordinary GPS system. Now, with this technology, we can get the quality in grading, passes, compaction and paving, and get the progress at interval level. What is the progress by remotely sitting in our offices and recording the compacted soil stiffness with the color display. Also, the built data can be achieved on daily basis. Because why this technology is now attracting to us? Because all this data, day-to-day data, within 24 hours, we will be able to get it, and we will utilize this data in our digital twin. In digital twin, you can easily put the progress, and that progress will automatically be fetched from the site to in our digital twin model. So this will be used in that digital twin, and this complete process will also remove the errors in the drawings in the beginning itself. It is a faster way to collect and store the data in the digital forms. We need in future we require the data in the digital form because of our various processes required in the 3D modeling of our complete projects. Then it will also enhance the safety. It also helps in keeping the record of compaction of the subsurface materials and its target density. As I already told you, the soft spots or the soft pockets in the compacted material can be identified and can be taken for further action by deciding a certain percentage for a segment, say for the segment of 700 meters in the width of 8.75 meters. If these loose pockets are more than 5% or say more than 15%, we can ask the agency to relay this or do the compaction, redo the compaction so that we can reduce the soft pockets. Now, in case of paver, we can capture the temperatures. See in this portion, there is temperature difference. There are certain pockets where the desired temperatures were not there. So in this way, we can get the results. In this particular stretch, if you see, the late temperature is less than 70 degree, then 70 to 140 degree, then more than 140 degree. No stretch is more than 140 degree. Most of the stretches is generally 70 to 140 degree. But there is a line where the laying has been done with less temperature. So these data can be available with you through this technology, which can be utilized for further necessary action, whether to do some mitigative measures like fire can be put this with this sprinkle of sand if authority engineer permits, or whatever the mitigation measures we have to decide accordingly for removal this uncontrolled temperature spots. We have laying of uncontrolled temperature spots. These are the certain points where we have captured the data for temperature. So all this data can be fetched out from this technology. And also later on when you will come across, will go ahead with this technology, you will find lot of improvements. You will suggest lot of improvements and lot of things that we can fetch out from this technology. Now, Just see this Saurabh, our PD in Lucknow, has done this charting. In this chart, you can see the tolerance limit of the WMM layer with the conventional method and with the AMG system. In this, every pocket, this is 0.413, this up to 16.5 meters, and for every 10 meter of chain edges, the levels has been taken. The levels which are more than 15 mm, they have been pointed out in red portion. So in the conventional, we have this much of discrepancies, and by adopting this AMG technology, we are able to remove such red patches. We are not got this red patches in this technology. A better level is a better thing, or better SOP is in case of AMG for keeping the surface level in tolerances limit. So this is the result that we are getting from this technology. Also, when we see the levels of DBM layer, there are a lot of discrepancies in the conventional method where the level is more than or less than 15 mm. But in case of this machine guidance control system, that has been removed and that has been brought to the limits in a better way. So by adopting this, we are able to fetch the quality. Now, how many manufacturers are available for this technology? One is Topcon positioning system, another is Trimble navigation, and this Trimble navigation is helping the PNC for doing the work in Lucknow Kanpur. This Lucknow Kanpur stretch can be seen, and our PD Saurabh Chaurasia is already available to guide all of us or to share all the informations. And the another company is Leica. Now the costing part. At present, this 3D machine control technology is costing somewhere around, for each equipment. For grader it is 70 lakhs, for compactor it is 35 lakhs, for paver it is 1.5 crore because of this robotic total stations. If we see for a project of 35 to 45 kilometers for the 2 years, it is generally costing 800 to 900 crores. The requirement of such equipments is, we have assumed as grader to be 5, compactor to be 4, paver to be 2, then again tandem paver to be 2. Where there may be some more pavers which are not deployed with this technology. That can be do the primary or the initial work, but finally at the final stage of layer, we can complete the process with these equipments. So these equipment will generally cost us around 7 crores. Nowadays, it will definitely come down when we will use this technology in all our projects. This technology will come down. Cost of this technology will come down, but at present it is somewhere around 0.75% of the total project cost, which is nothing. The comfort that our PD, our authority engineer, and our contractors are getting from this, the speed of construction that the contractors are getting from this, that is much more advantageous rather than investing this 0.75% of in the total project cost. These are certain things that we have planned. What should be our output in motor grader? The embankment layer thickness of 250 mm as per ISC 305, that can be done and that can be reflected in color coding, as we have mentioned in the third column. Similarly, in case of soil compactors, the vibration passes for the class 4.3.3.2 of IRC 97 can be done with the color coding. And in this case, the pockets, loose pockets can be identified in the percentage of area. Now, our IRC in the few days, in the coming years, we have to include in our IRC that any stretch which is less than 5% or 15% or 35% of these loose pockets, this has to be redone. At present, what provisions do we have? For every 1,000 cubic meter of earthwork, we have to do a test of sand replacement. And for a thickness of about 250 mm in a width of 30 meters, at every 133 meters, we have to do that test. And that test represents this 130 meters. But in this case, the compaction is available at every point, at every pocket you can fetch from this technology. Similarly, ICMV, the accelerometer, can be mapped in the form of percentage of area. Then again, the level of asphalt layers can also be done in the color coding for its tolerances limit. Then laying temperatures can also be fetched in the form of color coding as per IRC clause number 5.2, second para. And from this technology, what we have observed in Lucknow Kanpur package, the desired output from the software and instrumentation defined in HAM contract of Lucknow Kanpur package, it is under implementation, and this has been done by our ex-member Shri R.K. Pandey sir and his team. Presently, Saurabh is doing this work. Saurabh and team, this complete PNC team is doing. NHI is proceeding in other projects also with inclusion of the text in bidding document at Schedule D. In this contract of Lucknow Kanpur, with the approval of SFC, this text was introduced in chapter 5 also, in definition part also. But at present, what under the guidance of member sir, we are putting this text in Schedule D and Schedule B only. We have decided what text to be put here so that this technology can be mandated to all the contractors, and all the authority engineers and the PIUs or PDs, they can get the results, they can get the output for deciding the further course of action. We are getting the compaction, we are getting the levels within the tolerance limit or not, we are getting the temperature, laying temperature. All this data are with us to decide the further course of action. At present, we are not able to do this, or we are not able to basically control this to get the quality output. This complete system has been monitored. Site has been visited by the NHI headquarter also and MORTH staff also, the Lucknow Kanpur stretch. There were certain challenges were also there, like availability of network, accuracy of the established TBMs, analysis of the reports, the trained operators, and the less agencies to assist in implementation. But anyway, by disseminating this information, what initiative our chairman sir has taken, and he has asked us to disseminate this information to all the stakeholders. Accordingly, we are proceeding with this capacity enhancement program, and also we are putting this in a workshop to be conducted on 3rd in afternoon session, where after seeing this, you can put your questions, you can put your queries, so that we can note that and we can address that and we can include in our complete system of adopting this technology. Further, the key points of the text to be added in the Schedule D are, we have introduced in Schedule D the definition of the machine guidance control system. Then the obligation of the concessionaire, we have mentioned in that. this will be done at his own cost. Like he is using the grader, he is using the compactor. Similarly, this technology will be equipped on that instruments. Further, the construction of projects, its detailed specification has been mentioned, in which the centralized monitor software, information about the centralized monitor software has been mentioned. Preparing the design data, processing results has been mentioned there. 3D machine control system or motor grader for accurate grading to design. Then for pavers and compactors, then capturing the temperature, and also the data file transfers from the CMS to our digital twin model. All these things have been mentioned in that text. This is the sample of the text that you are going to put in your schedule D. Or I'll request all the GMs and CGMs and also the PDs to this text is already available, and I will share with you all what chairman sir and member sir has seen it, and they have corrected it, and now it is ready to use in our contract document in the schedule D. And also the three texts are also there to be mentioned in schedule B also. So this is a simple. And in case of anything, I have already mentioned this is my email ID, and I have also in the chat box I have also mentioned my this mobile number, so that you can share any information for this technology. Now, this is what our today's subject, machine guided control system. In this case, if any questions are there, we will definitely deal today also. And I have shared just this whole information to all of you to get ready for a workshop to be conducted on 3rd, and we will discuss the same thing with the digital twin also on 3rd of January, so that we can come out with other challenges which I have not covered, and you people can suggest improvement also that can be fetched from this technology. So let us stop here with this ATMS. Oh, sorry, the automated machine guidance control system. Now let me give you a small introduction to digital twin also. This is the another thing what our chairman sir has desired, so that we can adopt the geospatial policy of Government of India for our digital solutions in advancing the India's highway infrastructure. And in this digital twin, we basically what we are going to do in this digital twin. Let me tell you through the slides. This the National Geospatial Policy 2022 generally caters for digital evaluation model, geospatial knowledge, then mapping of surface and subsurface infrastructure, digital twin for major towns and cities. Now, taking this into cognition, NHI took the lead to use this geospatial data in highway sector in the form of highway information modeling platform. Now we are creating a highway information modeling platform on which all this data from the site, from automated machine guidance control system, and from what our designers have designed, that 3D model, that will be created here on this model. And we will do this 3D MGC control, machine guidance control system, and also we will do the multimodal logistic infrastructure, like integration between highways to flyways. In the coming days, as we know, this is one of the things that we will do this highway information modeling platform, in which I'll show you a a video where you can see what are the things we are going to do in this highway information modeling platform. This I have already discussed you. In the coming days, you can see this news, air taxis are coming. So we have to integrate these flying machines to land besides our highway. This is one of the intersection in the Bangalore-Chennai Expressway where RO Bangalore has done this black spots for landing of these machines. So these are the things which we have to do in keeping in view the 2047. So for this digital twin, Chairman sir has floated the concept in April, like to create a model or to do the things BIM for the highways. BIM is generally used in building and being used in by the various other agencies. So we have also adopted in two of our projects. One is DPR of 104 kilometers in Chhattisgarh and one project of 29 kilometers in Bihar. The process is under creating this digital twin is under process. This is will be discussed in the in the later presentation in the later on third. What we are going to do in this, the building information modeling system, which is being adopted by this Airport Authority of India, CPWD, Metro Rail, NHI has attempted for highway information modeling platform. This is a customized solution and not a software project. In this, we will manage the complete data management, central repository of the executed works. Then from that, the data science and R&D will be done. The voluminous data will be handled, and the integration with the data lakes, what we have developed. And is in this digital twin, in this platform, what we will do, design driven 3D digitized model with walkthrough. It is a digital twin. We will do a design driven 3D digitized model of our project. What we have envisaged in schedule B and C, that will be reflected in a form of model. That and this model will be featured with scheduling. Lot of our officers are telling that we are not concentrating on the scheduling part. We don't know out of this 50-kilometer stretch or 47-kilometer of project, which are the segments are on the critical path. And critical path means with the decided number of resources, what number of plants, how much crushing plant are there, how much bituminous plant are there. With respect to that, what are the things, what are the segments are on the critical path? This can also be captured through this digital twin. Even time-based costing also can also be done. Means as soon as you will progress your work, your value will automatically update it. This much value of work has been done after the approval of your RFIs. Then 3D machine guided control system will also be there. Then from that, and this will be powered with artificial intelligence. And later on, it will be developed by you people for the different updated versions. Like you will develop a module for road safety. You will run the vehicle on the speed of say 140 kilometer. Virtually, you can run the run the vehicle at the speed of 140 kilometers, and you can see elevation is super elevation is there or not. All this thing you can develop with this on this model. Now, what is the necessity of this digital twin? It is basically a way forward towards the 2047, and a digital twin policy for infrastructure is to leverage this PM Gati Shakti program. Now, this digital twin establishes a coherent guideline for authority, contractors, and consultant to ensure absolute transparency. Now, this absolute transparency, definitely, negative part is this: the contractor will not like to accept this easily because of this absolute transparency. But definitely, consistency and efficiency will come, and improved productivity will come. So we are trying to proceed with this, and your thoughts, your vision, your suggestions are invited so that we can include it, because you are the force and hands of our chairman. You can give us the information, and we will take up all these informations, all these suggestions to improve our SOPs. Now with this digital twin, definitely we will address the quality, the compaction part, as I already told you, then certainty, the project completion, LA and position, then working with insufficient survey data. This is the main thing that we are facing this challenge, because lot of agencies are doing the work without the survey, without the GPR survey, without knowing the things under the ground. We are proceeding with this, and then we are mitigating those things in the form of change of scope. Later on, when this complete highway information modeling platform will be a matured one, then we will totally remove this COS and EOT. This will never, this will be a history then, when this complete highway information modeling platform will come in a matured form. At present, it is a concept only, and it will be improved with the suggestion of you all. Also, the less control over the scheduling that can be addressed through this, the real-time assessment of desired extra equipments at certain, after passing certain time on the project. Say project is about 2 years. After passing of eight months, the progress is 2%. Now, what are the extra equipments are required that will be triggered from this platform to this digital twin model? Even it will trigger your payment also. Even it will trigger your other required things which will be developed during the course with our AI. Also, the system of access payment. I have already told you the absolute transparency. So the payment will also access payment or less payment. This can also be addressed from this platform. This is what we have modeled to a picture. What will be this highway information modeling platform? Basically, we are doing survey, geotech, then designing the highways, then designing the structures, planning the utilities to be shifted. Then we do our BOQ. See, BOQ is the basic thing that we have to do. We have to adopt. BOQ is the basic thing that is required to address our COS. If BOQ is available in the starting itself, the value is available in starting itself. Say the value is somewhere around, say the project value is 480 crores and that is bidded into 620. So, but the BOQ has to be remain same. Values to be remain same. In the last, that rebate part will be deducted. But that BOQ should also should have been taken by each of us in the starting itself for the complete project. This will help in deciding the negative change of scope. Nowadays, lot of reduction in scope of work is coming from various PIUs, and we are not able to do this work. We are not able to do that work, and this reduction of scope of work, what our senior officers have already planned, they have already thought of. Now we are reducing it, because of course it is correct, when we are not getting the land, we can reduce it, but all the times it is not advisable to reduce the scope of work. But anyway, I mean to say the construction time, here in this construction time, then modeling, then animation, then O&M, tolling and ATMS, all these features will be brought to a one platform. This is Highway Information Modeling Platform to improve our better understanding, quick decisions making, variation, COS, triggering the billing, EOT, COD. This will be the output from this complete system. This is the pictorial view of that. And what I want to say from the design driven model, you can see in this LS, there is a flaw in this profile. Here it is a high, here also it is high, here it is a hillock, where we are putting this profile at the putting this profile at the low level and providing this retaining wall. Now, whenever this will come to a member, this will come to a SFC, or it will come to you as a PD, you will definitely ask, भाई इसको यहाँ ऐसा क्यों रखा है, इसको आप ऊपर क्यों नहीं करते हैं, जिससे कटिंग भी कम होगी और हमारी रिटेनिंग वॉल भी हटेगी. तो इस तरीके की जो एग्जांपल्स हैं, इसको जैसे ही आप कहेंगे तो हमारा ये जो मॉडल है, this should immediately do that. I mean to say a design driven 3D model. So in this case, as we have included this raise the profile, our retaining wall is removed, its costing will be reduced. All this thing will come in the discussion itself. Instantly we have to do that. So this is what our aim is to bring in from this highway information modeling platform. Now let me introduce a concept, what you can say, conceivement of this complete thing, what we are planning to do from this digital twin. Another just 10 minutes. So what we will do in digital twin or 3D modeling, this is a project of 104 kilometer of Chhattisgarh. This is 50 kilometers and this is 50 kilometers. So we have introduced here our complete DPR. This is not in the digital form because at present we are not ready with the digital drawings. We have only the PDF copy of the drawings. So we have already included all the DPR, the contents of DPR here, like this cost estimate. It is all the cost estimate has been mentioned here. Then this drainage plan. This drainage plan, it is a PDF copy, but we have to keep the digital copy of this so that we can operate and we can move or we can use the model in the digital form. So this is the thing. Now, when we click this is the various stretches. In this 104 kilometers, there are 20 cross sections. And that 20 cross sections are used about 697 times. Say 70 meters, 140 meters, bridges say 40 meters. So those 20 cross sections have been used about 697, about 700 times. So 700 segments of estimate will be created. Its timeline will be created, and accordingly it will be linked on this platform so that we can get the information at any time. Now, that 3D model will be something like this. This is the thing what we have envisaged in schedule B and C. This is on our satellite map. This information, what is information of earthwork, will come through from our automated machine guidance control system, and we will create a 3D model during the construction as a part of our digital twin policy. You can see this model has been created. It contains a BUP, it contains a flyover, it contains a bridge. So now you can see in this complete model, we have this drawing. This drawing CAD plan is there, in which we have not paid attention to provide a chute drains. Now, whenever rainfall will come, the water will accumulate here. So this thing, through a model, we can improve. Even in this drawing, the connection between this WBM crash barrier and to this parapet wall of this culvert is not been connected. So this drawing, this model didn't connected this. So all this thing, when we will see in a form of model, we can see these are the things that we have to improve. This is the example of the modeling part that we can improve or virtually construct our projects. Now here you can see this shoots. These are not connected to this drain. This is the part that we have to improve in our drawings. And when a contractor will give this model, you can easily see the things in the starting itself. What are the lacuna are there in case of marking, in case of putting this electric poles. Further, you can see this line drain has not been extended. Maybe in this portion, unlined drain was planned. So we have to provide the unlined drain so that this water can easily go through this drain. So all this drawbacks in our drawings can be seen through this model, can be taken for mitigative measures or can be taken for corrections through this model. Nowadays, there are certain consultants which are using this, but all the consultants are not using. We have to ask them to please use this so that we can improve our DPR part also, and we can improve our DPR by constructing or not constructing, by creating this virtual model, by utilizing this highway information modeling platform. Now, in this case, you can see this is a flyover. Now, in this flyover, the drawbacks in our islands, the drawback in our, let me tell you a very small thing. When a person is coming from this side and it will go towards this, it will have a difficulty at this point. It is a, this notch will interfere in going from this direction. All this thing has not been covered in this drawing. That is why the model has created this. We have to do the blunt here, blunting of this structure. So as soon as we will see the model, we can improve our drawings and DPR part and correction also. One more thing I would like to share with this model, ki generally now here also you can see in one of the segment the culverts have been provided. Now these culverts have been provided and even our service roads are kept at a height of 2.5 meters. So these service roads are generally to cater this people, adjoining people. But because of this culvert, we kept this road about 2.5 meter high, or say 1 meter high, or 1.5 meter high. Now, by keeping the service road at the highest higher level, generally the people used to create the problem in case of this Doblapur, in case of Karnataka, when I was over there, from Devenhalli to Hoskate Road, there people are not allowing us to do this service road because the level is high. And we have kept the level high just because the contractor has a tendency, or it is obvious that this height of RE wall will be less. And most of the part is being used by the earth. So we can take a cautious decision here let us provide this causeway here, and water can pass over this service road, or we can provide the series of pipes so that water can that perforation can be increased in the horizontal direction. So all such mitigation measures can be taken so that the problem which PD generally faces, or site engineer generally faces during the construction, that can be addressed from its in the starting itself through this model. Further, what we have envisaged in our schedule B and C, in some cutting portion, we have planned for retaining walls. So these models will fix all the stakeholders, consultants, contractors, and us, to provide the retaining wall. When we have already shown in our model and what in our understanding that the retaining wall is to be created, so we will do that by creating this model. Now, this data will come from automated machine guidance control system, and gradually it will build. Presently, what we are facing the challenge is that the contractor generally provides the toe wall, and we have mentioned in the schedule B, it is a retaining wall. So all these things can be sorted out in the starting itself by creating this model. Now here, one minor bridge is there. So I have tried to capture through this clipping a flyover, a bridge, a retaining wall, to show what we want in our digital twin. We definitely invite your comments. We definitely welcome your suggestion for creating this digital twin, what our chairman has envisaged, so that we can improve our quality. Now, this is the design driven 3D model, what I have shared with you. Another two things, what you people have heard, that 4D and 5D, that has to become in this part. So we have mentioned here the complete program of the project. What are the which chainage will start at what time and end at what time. All this thing will be included in this platform, and it will be a link with our construction. Let me tell you how we have planned to address those things. The bridge that I have shown you will be constructed, and its estimate is already there just below this. So as soon as the activity will progress, its financial part will also be updated. Somebody has need not to depend upon the officer that he will certify the payment. When this stage will come and it will be approved, the payment will automatically triggered from this platform that he or that agency is qualified for the payment. So this concept or this segment will also be captured from this platform, that costing part, time-based costing part. I mean to say time-based costing part. As regard the this is the different progress of the work. Whatever progressing we are achieving from the with respect to time, we will capture it and demonstrate it here with the percentage of progress. And this percentage of progress will also be accompanied with further requirement of resources. If any instruments or in any equipment is required, that can also be triggered from this. This is what we have envisaged to incorporate in this digital twin. So this is what I want to share with you all. Now I'll play a 2 minutes the video clippings that our friend and our one of the dedicated PD Saurabh Chaurasia has created for you all.
Yes, sir. Please
Now
pause
I
for
am
them.
sharing this grading part.
In the AMD technology,
Is it okay? Share हो रही है?
बताइए बताइए सर।
engineer have to set up the GNSS base station at the nearest known TVM. Whereas in the conventional method, highway surveyor have to start with total station to mark horizontal alignment, and accordingly, another team member transfers the edge site point by using the measuring tape, and then second team member marks white chalk border on all points, and at these markings, a stake rod will be placed. Reduced levels are marked on the stakes with the help of auto levels. The grader operator start doing grading with breaking the heaps. Operator breaks the heaps and do the profiling on pure guesswork. Whereas the AMG technology essentially bypasses the traditional process of grading by using stakes. Instead of giving site plans to the surveyor, who uses these plans to manually set the stakes, and then having the machine operator, visually guided by a site engineer, read those stakes. A 3D control system puts the site plan on a screen directly in front of the machine operator. An onboard computer in the machine's cab has a digital copy of the site plans stored in its memory, and a machine receiver combined with various onboard sensors. The grader operator breaks the heaps, and profiling is done as per the guidance received from the display mounted on the cabin. The operator can see the real-time cut and fill data of profile, and he can spread the material accordingly. After profiling, in conventional method, operator is purely dependent upon the guidance received from the site engineer, and while laying the material, he has to stop each time so that the site engineer can check the levels using measuring scales, whereas with AMG technology, system determines how far the cutting edge is from grade level and sends a signal to the hydraulics to drive the blade to grade level. The productivity achieved by using the technology is 336 cubic meter per hour, whereas with conventional method, productivity can be achieved only up to 113 cubic meter per hour. Another advantage is that we can work day and night with technology fitted grader. However, in conventional method, operations can be done during the daylight only.
So Saurabh, our PD, has done this work, and it is his voice in which he has created this clipping for you all. Another for compactor. Let me play the video of that compactor also.
Advanced compaction technology. Once the grading process is done, compactor starts compacting the road using AMG technology. In AMG technology, a GNS receiver is mounted on the top of the cabin of compactor, which helps collecting position data of compactor drum. With onboard screen mounted on the cabin, operator gets the guidance about the number of passes, and once target passes achieved, is screen indicated by green color on that area. The authority can monitor the compaction process remotely. In conventional way, there is no option available to monitor the process remotely, and also there is no way in which compactor operator gets the guidance.
Also, in case of paver, how we are proceeding with, how this project director has proceeded with this paver. Let me share this also.
Comparison of conventional paving versus automated machine guidance technology. In the AMG technology method, the surveyor has to start with setup of a robotic total station using known control point. After this, the surveyor connects the robotic total station with a 360-degree prism, which are mounted on the top of the paver screed. The onboard system will calculate the position at the bottom of screed edge. Whereas in the conventional method, First, the survey team will provide the center line and mark the points on the proposed bed, followed by fixing of peg rods on the markings. After this, by using auto level, the civil team member fixes the reduced level as per the FRL sheet of the proposed crust. The trucks start loading the material, the paver, and both the pavers start to spread the WMM material. In the AMG technology method, on-board monitor is mounted on the paver in which the surface design of the proposed crust is loaded. The 360-degree prism calculate the current position of screed and through design machine calculate the level adjustment automatically. To ensure better quality with the help of a grade check system and controller, the engineer can check the grade levels easily during laying. In the conventional method, paver is following string wire using the contact sensor. By using a thread and a measuring scale, a worker checks the level of the layer. If there are any changes in the level, the worker adjusts it using the side panels.
So, share with you all, let us go ahead with this technology and adopt this technology so that we can achieve the quality work and convenience to us also. Chairman sir has already taken the initiative for this thing and मैं एक इसका सूत्रधार हूँ यहाँ पे. आप सब लोगों के पास जो भी विचार हो, जो भी सजेशन हो, वो आप बता सकते हैं. We can proceed with that. Thank you very much now.